Students, today I explain chapter 4th, refraction of light at plane surface. Okay, it's very important chapter, and maybe you feel that it's very hard, but students, follow my lecture. It will be very easy, and what I am teaching, you just do this thing, make note in your copy and practice this thing. 80% question, 90% question, probably all question you can solve. Okay, no problem is there. So follow my lectures. Okay, so what is refraction? Reflection, students, you know, when light rays fall on a surface. Students, suppose this is the surface. I have drawn already to proper understand you. I hope you can watch it properly. So when light ray fall, when it will reflect back on the same medium, that is called reflection. Okay, now students, maybe your question arises, suppose there is a two surface between air and water. Okay, suppose when light ray fall on the pond, okay, then air up above the pond, that is air, but inside the pond also, as that is transparent little bit pond water, so it will fall down and it will go directly inside the water. So what is the way that light ray travel? That is easy directly enter on that straight path, or it will bend something. So students, a bending takes place. Okay, bending of light rays when it will pass from one medium to another medium. Okay, that is called refraction of light. Reflection happens in the same medium, in air medium. So and refraction means it's between two medium it happens. Okay, one will be rarer and rarer to the denser medium. When rarer to the denser medium, the light ray will go, you know, it will move towards the normal. Students, you know which one is normal. Normal is perpendicular to the surface. Always if you draw a perpendicular to the surface, you got the normal. Okay, so here it is the normal. You can see it is the surface. So perpendicular of the surface means 90 degree with the surface. That is normal. So it is normal. I have write here perpendicular to the surface for your understand. So when a light ray fall, incident ray, rarer to the denser, because above air is rarer and water is the denser. You know, so water is more denser than air. That's why this is called rarer to the denser medium. When light, I am just counting one single light ray. When a single light will fall over here, you can see it will move towards the normal. When move to rarer to the denser, it will move towards the normal. So bending of light takes place when light ray move from rarer to the denser, it will move towards the normal. Okay, so that is called incident and it is called refracted ray. Okay, not reflected. Reflected ray is different. In the same medium, some reflection also takes place here above portion. That is, we will not count here because your book, it is refraction. We are studying refraction. Okay, so when incident ray, it will move from light ray, move from rarer to the denser, it will bend towards normal. Okay, bend towards normal. Students, you remember this. Okay, similarly students, when the opposite happens, above water, below air, so light ray will, when move from water to the air, what happens? Just opposite, it will move away. It is normal, you know, it is normal. So it will move away from the normal. You can see this is the path of the light. Okay, means rarer to denser to the rarer it will go, means it will move away from the normal. Okay, now students, this is called I. Okay, angle of incidence. Always, you know, you will not make this angle. Okay, no, not surface, with the normal and the incident ray. Angle between the normal, always draw the angle with the normal. Okay, with the normal, this is the normal and this is the incident ray. So this will be angle of incidence, and refracted, angle of refraction over here, R, IR. Okay, you just remember this thing. So angle of incident and angle of refraction, here you can see. Okay, you can see over here with the normal. Okay, not with this surface. Never draw the angle with the surface. Sometimes you may do the mistakes. So actually the light ray can travel this straight line means it can travel like this way, but no, it will move towards the normal because of the moving from rarer to denser. Oppositely, denser to rarer, it can move like this way straight, but no, it will move away from the normal. Okay, these two characteristics has seen when light ray travel between two different medium, and it is called refraction of light. Now students, one interesting case when no bending. Okay, normal incidence. Normal means incident through normal, this line. When light ray, some light ray will come from normally also fall on the surface. Okay, normally means through that perpendicular, means suppose this is surface, so it is the normal. Light ray also fall on according to that normal. Then what happens, students? There is no bending happens. Okay, no bending happens, directly it will pass. Okay, means there I0 means angle of incidence is 0 in this case. You can see there is no angle between normal and incidence ray, both same. This is normal with the surface. Okay, and this is also incident ray, where light ray incident fall along with the normal. Okay, so there will be no angle, there 0, there will be angle of incidence is 0 because it is totally fall on that same line. Then what happens? There will be no refraction, no bending happens. Okay, light will directly pass to the one medium to another. It will irrespective on the medium. It can be air water or it can be water air. Okay, that is the three things, students. What is the, these are the three types of refraction used to see for the light. Now students, what is the cause? Cause, students, you can read your book, you open your book, then you can cause, you can easily understand. It has written that when light ray pass from one medium to another, direction change because change in speed of light. Okay, because of course a speed of light in air is different, you know, 3 into 10 to the power 8 like this meter. Okay, but you know, in solid path or inside the water, that speed is not same. Okay, we are doing in vacuum, it is 3 into 10 to the power 8. Okay, similarly, you know, that's why as speed of light change, bending happens. So inside the air we know a different speed of light, but when it will move inside the water, its speed different. So here it is falling the light with the same another speed, and after fall on the water there is another speed. That's why, student, different speed means some bending happens. So it's due to the different in speed of light going change from one medium to another. Okay, that's why the bending happens. Okay, now students, maybe you think that so here also to speed will change, normal incident from air to, because the speed of light in air and speed of light in water is not same, so here also bending takes place. No, students, for it is called normal incidence. Okay, for normal incidence, students, I is equal to 0, angle of incidence is 0. That's why whether also the speed is different, but direction is not change. Okay, here direction of light not change, direction of light not change. It has written in your book properly, you can see. Now come to the law, students. Same, first law is quite same with the law of reflection. Incident ray refracted, always I am saying not reflected, refracted. Incident ray, refracted ray, and the normal at the point of incident all lie in the same plane. Okay, all lie in the same plane. Second point, students, I will explain after some time, that the ratio of sine, you just remember this, ratio of sine of the incident angle, means angle of incidence, to the ratio of sine, okay, to the sine of angle of refraction. Okay, once again I am repeating that the ratio, you can see ratio sin I by sin r, so you will write like this way, ratio of sine of angle of incidence to the sine of angle of refraction is constant. Okay, is constant, and that constant is considered as nu. Okay, this sign is called mu. Okay, MEW, mu. Okay, so this is called mu, and this constant is known as the refractive index. Okay, refractive. So it's known as Snell's law. I'll explain after some time. So what is Snell's law? Snell's law. But here just you remember this thing. That's sine of angle of incidence to the sine of angle of refraction is equal to ratio is equal to constant. Okay, for a pair of given medium, students, you just remember this point is very vital. For a pair of given medium, suppose air and water, these two medium, this is constant. Okay, it's not that for a pair of medium this value is constant. Suppose you can see air and glass, there is also another refractive index will come. Okay, another value will come, but that is constant for air and glass, always constant for that two medium. So for a given pair of medium, this value is constant. Okay, it's not that it's universally constant and it will applicable for all two medium. No, for a given pair of medium, this value is constant. So students, I hope you understand what is the mu. So that mu, if the value will given like that, mu 1 2, that means refractive index of second with respect to first medium. Okay, so 2 means second medium can be water, air, that's why 2 and 1 will be given. Okay, air, water, glass, whatever it is. Okay, it can be some refractive index of glass in the medium glass to respect of air, it can happen. That's why I 1 2 has given. So it means mu 2 or 1 means, generally you remember, okay, refractive index of this second with respect to 1. Now just I am coming to explain what is refractive index. Students, when light ray pass, you know, in rarer medium the light ray passed fast, speed will be fast, and denser medium its speed of light is slow. That means, so student, denser means optically denser. Remember this thing, because if I give example kerosene and water, you know density of kerosene is lesser than the water, it will float on water, that's why, but it is much more optically denser. Optical density is greater than water. Remember this thing. Normal density, forget. Here we are not talking about normal density. Here we are talking about optical density. Optical density means when light pass through that medium, how it will affect the light. Is it dense towards the light or not? That's why optical density is totally different than the normal density. Don't think about that. I already give the example. Optical density of kerosene is much higher than the water. But normally, you know, kerosene is very light than the water. That's why less denser. That's why it will float on the water. Okay. So forget about normal density. It is optically density. Now, what is optical density? Same, students, optical density represent as the refractive index. Okay. Same sign, mu. Okay, optical density means measure by refractive index. So refractive index is the measure of optical density. Means if refractive density index is higher, then the optical density also be higher. You just check here, you can understand. Students, if mu increase means optical density increase, means denser, optically denser, that means speed of light will be less. You just remember this thing. If a object is more optically denser, its speed of light will be less. So it is inversely proportion. Nu inversely proportion with v. V means speed of light. You just remember this. Speed of light increase means refractive index less, means they optically less dense. Okay. So students, here just see here example has given. Suppose that is mu 1 and that is mu 2, and velocity of light in this medium is v1 and v2 below. Suppose it's I am giving air, it is water. So air's optical density mu 1 and water's mu 2. So velocity of light here also different medium, so different velocity of light will be there because their density is different. Their optical density difference means their velocity will be also different. Light speed, okay, speed of light. So if you write that mu 2 by mu 1, it will be v1 by v2, because you know inversely proportion mu 1 mu 2 v1 will be there, because you know inversely proportional. It is, if directly proportional, so it will, if it was directly proportional, then mu2 here v2 will come. Okay, so as inversely proportional, so mu2 by mu1 is equal to v1 by v2. You can solve it, no problem. So this we can write like this. Okay, mu1 with respect to this. So refractive index of second, if you say second means water, with respect to air is equal to velocity of light in one means opposite in air by the velocity of speed of light in the. So students, you know, speed velocity in direction will applied means it will velocity converted, speed converted into. So you can say also, so you can, it will better if you say speed, no problem. So you can say refractive index of second with respect to first. Okay, so in question some maths can become. Okay, some maths can become. So I am showing you. Students, this question also present in your book. You can see that the velocity of light in air is this 3 into 10 to the power 8, and velocity of light in glass is this. Okay, so that means mu g by mu air, okay, will be va by v glass opposite. Okay, that means value will come 1.5. okay, value 1.5 means mu ag 1.5 means, students, two types of means will come. Okay, glass is 1.5 optically denser than air, because you know g this side compare with mu 1 2, that means ri of 2 with respect to 1. Okay, you compare with this, means refractive index of 2 with respect to 1. So refractive index of glass with respect to air is 1.5 times. That means refractive index 1.5 times means optically denser also 1.5 times. That's why as glass is optically denser 1.5 times, hence speed of light in glass is less. Students, just rewind this and once again you listen. I think you will fully understand. So any body how much denser than the normal air, you can easily calculate, and you can calculate the velocity also on that medium. If the refractive index will be given in question, you can find, if one velocity is given and if ri is given, you can find the velocity on that medium also, no problem. Students, these numericals used to come. I hope you all can solve the numerical. Now students, glass is 1.5 times optically denser than air by this value we calculate. Similarly, we can say that speed of light will be reduced 1.5 times in glass compared to air. Okay, that speed of light will be less. How much less? 1.5 times, because you know refractive index 1.5 times higher with respect to air in glass. So in glass, speed of light will be 1.5 times less. Okay, so in glass, speed of light will be reduced 1.5 times in glass compared to the air. Okay, I hope students you understand it. If you don't understand, once again repeat the video, and I think your idea will be clear. Next video I will talk about Snell's law.